Hello, honorable members and all attendees. My name is Umayma Mejri and I attend Iwa Women's University. I have collaborated with Professor Doinshil, who teaches at Iwa Women's University, and also with a fellow student, Ms. Danaya. Our paper is about finding a log based proactive strategy to better secure the cloud. The content of the presentation is as follows. First, I'll be starting with an introduction, moving on to the motivation of the paper, leading to the background, and then explaining the strategy, then the conclusion, and ending it with future directions for the paper. With the current situation the world is facing with the COVID 19 pandemic, companies, universities, and organizations have been forced to using cloud. But the issue always remains as organizations still do not fully trust the security of the cloud. As you can see here in the graph, uh, which shows statistics dating from January to April 2020, you can see that the use of such services like Zoom and Cisco WebEx has increased rapidly. The increased use of the cloud resulted also in bad consequences, which is malicious attacks. According to McAfee Company, the attacks targeting the cloud services has risen by 630% since the start of the pandemic, which is a scary number actually. In a survey done by cybersecurity company called Fire on Cloud Security Intelligence report, 93% of organizations are concerned over the security of the cloud. Most of them were extremely concerned. The reasons for the concern vary, but the main ones are unauthorized access with 42%, insecure IPIs 42%, misconfiguration of the cloud platform also comes by 40%. The aim of this paper is twofold. First, to help companies and organizations manage their own resources by highlighting the current security challenges cloud computing is experiencing. And second, to propose a strategy with appropriate measures that should be adopted for an organization or a company to properly understand the security threats that their cloud is facing. Nowadays, with the increasing number of devices, more data is being generated, and 90% of this data are either wasted or manipulated. Data generated in a system can be used to provide the organization a better insight of their own infrastructure. Here comes the logging concept. Centralized logging can be very useful when attempting to identify problems with your servers or applications, as it allows you to search through all your logs in a single place, which makes troubleshooting an easier task for IT administrators. When it comes to logging, it is very important to be proactive rather than reactive. For an example, if you set streams to trigger alerts on unauthorized login, the IT administrator can get an alert via the email and handle the situation before any more damages can happen. As you can see, the following table is an example of centralized log. It is not raw. This is the log after it's been centralized. So you can see now it is more comprehensive and it would be easier to identify the problem. Because as is known, like logs are very essential in any system. This is why like we were inspired to base our strategy based on logs. Um, we propose a theoretical strategy to help organizations understand their cloud infrastructure on a deeper level, with the ability to put together a strategy to better secure the cloud. The first step in the cloud to do is to set a solution that would do a security scan of the cloud to detect any misconfiguration or security breaches. The second step is to integrate a vulnerability scanning tool with a number of security attacks increasing for cloud computing. The clouds need to be properly tested for any vulnerability to ensure its security. And finally, the third step is to monitor and analyze the logs generated in the cloud. This is done using a log management solution that provides real time analysis. Looking through the steps individually, the different steps are not sufficient alone. Like, for example, by doing a misconfiguration scan, one may find a misconfiguration but not necessarily the vulnerabilities that have been caused by the said misconfiguration. However, the whole strategy would represent a complete security scan. It is important to do a complete security scan because in the cloud, you have multiple users that contribute. So its state keeps changing and can make it vulnerable. Therefore, the problem can occur such as misconfiguration issues that would lead to major vulnerabilities. As the cloud is under constant threat of being attacked every second, it is essential to make sure its configuration and the services used in the cloud are always under consistent and up to date configuration. Because misconfiguration can compromise the cloud and its components by exposing its assets, by making it a target for cyber attacks. As mentioned earlier, according to Coalfire, 40% of organizations are concerned about cloud misconfiguration. Like, for an example, a misconfigured Amazon S3 bucket has resulted in the exposure of over 40,000 personally identifiable information from Australian employees working in government agencies and banks. The exposed data included passwords, the employees' names, and personal information like phone numbers, credit card numbers, and also in another incident in the US, the Tea Party PAC has publicly exposed around half a million US voters' data through its Amazon 3 bucket. Like here, as you can see, this screenshot is the example of the exposed data from the political party. It's like you can see like PDF documents with campaign strategies and also had personal information about the voters. Like from this, we can see how critical it is when the cloud is misconfigured. The first step we propose to do in the cloud is to set a solution that would do a security scan of your cloud to detect any misconfiguration to prevent security breaches. The security scanning of the cloud configuration is very important. For an example, it can happen that one of the developers has forgotten a data store open when developing a part of the software and leaves it open when releasing the application to the market. And that can cause a real security breach. This figure here shows a basic process of misconfiguration detection. Like it starts with data being collected in the cloud and then scanned to detect any existing misconfiguration. Here are some tools that can be used to implement in your cloud in order to be able to detect misconfiguration. First, we have Checkov. It is a tool for analyzing static codes for infrastructure as code. To detect cloud misconfiguration, it scans the cloud infrastructure. It is Python based, so writing and managing codes and version control like is simpler. Second, we have Terraforma, which is tool for static code analysis used for Terraform plans. It is designed to detect security misconfiguration. It provides output in TF-JSON instead of JSON. And then we have Cloudsploit. It is an open source project. It it can scan the cloud within seconds to detect any misconfiguration. It has also the capability to scan more than 95 security vulnerabilities across 40 plus resource types, consisting of wide range AWS products. It can detect risks efficiently and implement security features before launching your cloud infrastructure. The cloud's complex infrastructure can cause a lot of vulnerabilities. So it is very important to ensure detection of the cloud vulnerabilities. These vulnerabilities can be used and exploited as loopholes by attackers to take advantage for cyber attack. The vulnerabilities that an attacker can exploit are numerous. We have such as data breaches, malware and ransom, DOS, DDoS, data loss, insecure APIs, and vendor lock-in. As organizations still do not fully understand the different aspects of their cloud security, with vulnerability issues remaining as one of the top concerns, making them reluctant towards using the cloud. So, here comes a necessity for organizations to understand that the security of the cloud is a shared responsibility between the cloud service provider and the organization. Therefore, organizations should not rely on the cloud provider for security scanning. Scanning the cloud for any vulnerabilities is a focal point. So, the second step is to integrate vulnerability scanning tool with the number of security attacks increasing for the cloud computing. The clouds need to be properly tested for any vulnerabilities to ensure security. Even with the most advanced cloud providers, there remain some vulnerabilities that can be used as loopholes for any potential attacker. These here are some tools that can use in your cloud to be able to detect vulnerabilities. Here we focus, we have Nmap. It is a tool used for scanning networks. However, it supports only a few operating systems like Unix, Linux, Solaris, Mac, and Windows. We have Nexpose. It is an open source tool used for scanning for vulnerabilities. Its database is constantly updated weekly with new vulnerabilities by the GitHub community. Here we focus on Arcany. It is a vulnerability scanner framework based on Ruby, used mostly for web applications. Arcany Arcany can detect vulnerabilities like cross-site request forgery, NoSQL, SQL code injections. As you can see here in the figure, we tried to show the process Arcany used for vulnerability detection. You have the web user interface client. It provides single point of contact that contacts its grid of dispatch servers with a scan request. So the dispatch server would create an instance on that server. After that process, the web user interface client can communicate directly with the created instance to configure it for the appropriate scanning job. After the instance finishes the task, the web user interface client withdraws the data to store as the instance stops its task and returns the resource it consumed to the operating system for other instance or software to use in the future. Logs in any system are super important. They can provide key information about what is happening. It is well known that they answer the five W's: who, what, where, why, and when. So it is very important to have centralized logging in your system because it helps you identify problems and makes troubleshooting an easier task. Without centralized logging, IT administrators can spend hours to search through the logs to be able to identify the problem. So the need to include the real-time monitoring of a network becomes a necessity. That is why we propose in a third step to centralize the logs in order to better understand the infrastructure and to be proactive when it comes to troubleshooting. So, the third step we propose is to monitor and analyze the logs generated in the cloud using a log management solution that provides real time analysis and alert triggering functions to better manage the system. Because it is very important to be proactive when it comes to logs, organizations must consider the potential value of each and every possible log source. There are a lot of types of logs that are being generated in the system. And like here, there's like, this is an example of the logs that must be considered for log collection. We have like anti-malware software, like examples anti-malware, like antivirus and spyware. Also, like logs from applications. The information logged by application can be account changes, like user notification attempts, and authentication servers, and like firewalls, because firewalls they can inspect the content and ensure the state and integrity of permitted connections. So its logs provide a lot of information. And also operating system, because there are many varied operating system on servers and workstation and assorted network devices. So you're gonna have multiple different types of logs from operating systems. The choice of appropriate log management solution should come after studying requirements of your own system and must be capable to do like the following: uh, filter real time logs, help treat pre configured exceptions, uh, alert and trigger, give all users secure access to real time data. There are a large number of log management solutions to choose from, and as mentioned earlier, the choice of the solution should adapt to requirements of your own infrastructure. Implementation of log management solution is a bit sensitive and you need to configure it on your own. It's not as simple as installing something. It requires a lot of configuration, and basically you have to do it from scratch, like we say. Um, Here, as you can see, this is a table like comparing some of the most famous log management solution. We have Logstash. It uses Elasticsearch for both storage and indexing. And to visualize the data, it uses Kibana. And then we have Kibana. It is an open source analytics and visualization platform designed to work with Elasticsearch. It is also based front end for Logstash. It is written in JavaScript and Ruby. And then we have Graylog 2 is an open source log management solution composed of a server and a web interface. It has a lot of good features as it allows you to set streams in order to trigger alerts and search through logs in a comprehensive format. It uses Elasticsearch to store your streams like or alerts and Mongo database to store the actual logs. And then we have Fluentend. It uses Elasticsearch for both indexing and storage, and it is based in Ruby. To conclude here, the recent rise of attacks on clouds has been a major problem for companies and organizations. These attacks have resulted in mistrust between cloud providers and their consumers. Companies and organizations should be well informed of their provided cloud infrastructure and how to secure it. This paper aims to help companies and organizations manage their own resources by highlighting the current security challenges. Step 1 aims to avoid any major security breaches like the exposure of sensitive information by detection of misconfiguration in the cloud. The second step aims to secure the cloud against upcoming threats by detection of any vulnerabilities that can be used by attackers. And finally, it is important for users to better manage their system data by centralizing the logs to help be proactive when it comes to troubleshooting. To end about the future directions that we're going to take for this paper, we wanted to test this strategy we have proposed, but unfortunately, while writing the paper, there was no resources we have, like we had no access to a cloud that would have multiple resources to be able to study its infrastructure. But as future work, we would like to test how secure taking these measures. For example, in a first step, we launch an attack scenario before implementing any of the steps and see how the cloud can endure, and then test with only one step while implementing also an attack scenario, and then try to implement only like first and second step with an attack scenario. So basically, the idea is to implement the step alternative in an alternative way with attack scenarios, and then also try all the steps together and launch also a attack scenario and to compare results. To be like, the aim is to able to figure it out like how efficient this strategy is. Because for an example, like, the last step can find problems that the first step and second step might not be able to identify. So that is the whole point, to try to see how does these different steps work as a whole rather than separately also. This is a list of references. Finally, I would like to thank you for your attention, and I want to take this opportunity to thank the chair members and the committee for this opportunity to be able to present our work. This is an opportunity I will always be thankful for, and also for all the staff that is working and made this conference possible. I know it is very hard time for everyone around the world. I sincerely thank you so much.